So today we will discuss ambiguous context-free grammar. In the previous lecture, you have seen that there are few grammars for which you will find that for a same grammar, for a same input string, you will have the two different parse trees. So when you have two different parse trees for the same grammar and same input string, we call that grammar as a ambiguous grammar. So we need to remove the ambiguity of the grammar, otherwise uh, your compiler will not be able to process the instruction properly, and there will be always confusion to the compiler what sequence to follow and what exactly the statement structure means. So there is no specific rule to remove the ambiguity, or there is no any particular algorithm that will remove the ambiguity of the grammar. So it is possible to remove the ambiguity from the context free grammar, but designing the what we can say, the algorithm to remove the ambiguity from any grammar is unsolvable problem, because every grammar is different, and the way that the ambiguity can be removed from the grammar, that is also different. So there is no generic rule, and we can't set a generic rule to remove the ambiguity. So it's up to the analysis of the designer of the grammar to identify the ambiguity and to remove it. So, in the previous lecture, for this particular grammar and for this input string, you derive the leftmost derivation and the rightmost derivation. And from that, you derive these two different parts tree. And from that, we came to conclusion that this grammar is ambiguous. So, the ambiguity of the grammar of this same grammar, it is removed in this way. You can see this this grammar is how it is transformed to this grammar, right? This is your ambiguous grammar, and the ambiguity of the grammar is removed by making the changes like this. So if you observe in this grammar, so your e, it is expanded to e plus t, and your t, it gets expanded to t into f. So automatically your asterisk or your multiplication operation, it will come on lower level of the tree. So when it is at a lower level, so obviously this asterisk part will get executed first, and the answer of this multiplication later it will get added to the e. So anyways, this way the problem that which operation to perform first from this string id plus id into id will be resolved. So here just for the arithmetic grammar, they made that the operator having the they ensure that the operator having the higher precedence, it should come to the lower hierarchy of the tree. And by making these changes, that ambiguity is solved. So if you'll try to draw the tree for this, your this root node E, it will get expanded to E plus T. So this E, it will have three children. Uh, we check whether the parse tree for this, yeah, yes. So here you have this E, you can see this is your start root node E, and it is expanded to E plus T. So you can see here E plus T. These three children are of E. Then this T, it get expanded to T into F. And later here you can see that this E, it get expanded to T, T get expanded to F, F get expanded to ID. So if you observe, it is clearly seen that uh, if you want to perform this, so when you will go from bottom to top, So you will find that this asterisk will get performed first, and the result is in T, and then the addition of this E and T will be made, and it will get stored in E. So this way the ambiguity for the precedence get removed. Okay.